Right, continuing our study with trigonometric identities, let's use the multiple angle formulas. Let's start with the double angles. Notice the sine of 2u is 2 sine of u, cosine 2u, there's 3 different things. Tangent there, these can be derived from the sine, cosine, and tangent of a plus b. We're going to work 3 types of problems with these. Let's start with solving a multiple angle equation. All right, let's solve the sine of 2x times the sine of x equals the cosine of x. All right, the sine of 2x equal to the cosine, 2 sine of x cosine, sine of cosine sine, minus the cosine equals 0. Factor out the cosine, and we have 2 sine squared of x equals 0. Cosine equals 0, that's pi over 2 and 3 pi over 2. 2 sine squared x equals 1. Sine squared x equals half. Sine of x equals plus or minus the square root of 2 over 2. And so we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, now let's evaluate functions involving double angles. Given the cosine of u is minus 4/5, and notice we have u in quadrant 2. Sine of 2u, find the sine, the cosine, and the tangent of 2u. All right, notice we put a little triangle there with the appropriate sides, and then we plug in to the functions sine of 2u, cosine 2u, and tangent of 2u, which you have written down on a piece of paper and are in the process of learning so that you can use them without looking them up. This is an easy thing to do given these angles, to find the sine and cosine of the the double angles. Now, let's derive a triple angle formula and see what we get. Okay, let's rewrite the cosine of 4x in terms of the cosine of x. Cosine of 2 times 2x, 2 cosine squared of 2x minus 1. All right, and so then we square what we get, and notice this huge equation that we're getting here, and we've expanded it.